So with that brief introduction, it is my pleasure to introduce our first speaker, Chris Petit, who is the Manager of Technical Services with Passivhaus Canada. Chris provides technical assistance to members of Passivhaus Canada and municipalities across Canada with the Passivhaus Canada Technical Services team. As a member of several standards committees, Chris collaborates to improve energy efficiency standards and help make high-performance buildings the norm. Chris is a Passivhaus designer, tradesperson, trainer, and building certifier accredited by the Passivhaus Institute. He has provided design support and energy modeling services since 2008 with the Center for Sustainable Building Research, Clean Energy Coalition, Regenerative Design, and Certifiers Cooperative. It is my pleasure to welcome Chris Petit to our Builders Breakfast. And Chris, please take it away.
Thank you. I'll share my PowerPoint. All right. My name is Chris Petit. I'm with Passivhaus Canada. Passivhaus Canada is a national nonprofit professional association. We advocate for the Passivhaus standard through advocacy, education, technical assistance, events, and generally fostering community. We help build awareness and the adoption of the Passivhaus design and construction. I was a little bit curious. I know it's a builder's breakfast, but I was trying to figure out who's in our audience. If you want to put that in the chat, that's useful. And also, I'm just trying to gauge people's background and familiarity with Passivhaus, so I can try to gauge my presentation accordingly. So if you can do that, I'd appreciate it. So just a little history, the Passivhaus standard comes out of Canada. There's a history of pioneers with the Saskatchewan Conservation House that was in Regina in 1977. Super insulated building, airtight, compact shape, innovative heat recovery ventilator, solar gain through the glass. So a lot of the principles that are the standard today for Passivhaus were in this building during that time due to the oil crisis. And then later that was taken up in Germany. So they built their first Passivhaus in 1990 using the same principles. Both of these buildings still stand and are still occupied. We get excellent data about their performance and their continued performance has met up to the same expectations as when they were originally built. Just a little bit of background for carbon emissions. We consume 40% of the global energy use with buildings, and we contribute to about 30% of the global greenhouse gas emissions. So the built environment has a large impact when it comes to global warming, climate change. So what we're trying to do with Passivhaus is really look at space heating. We can really drive down the energy use in space heating, and then we also take into account, so you're getting about a 90% reduction of energy through the principles of Passivhaus construction, and I'll go into that a little bit more as I go through the presentation. We also try to do more efficiency in heating, appliances, lighting, and there may be cooling, but it's not required within a Passivhaus. So generally, a conventional building would take about 22,000 kWh per year. What we're doing is reducing that to get to net zero energy targets, and then when you do that big of a reduction, it's a lot easier to then cover that gap with renewable energy. Renewable energy is quite expensive, so it makes sense to conserve first and then add renewables when you're trying to hit net zero energy targets. So the BC Climate Leadership Plan, we're trying to make buildings ready to be net zero by 2032. The International Passivhaus Standard is a great way to do that. So, we want to make sure that you're, have the knowledge and experience to get there so we can meet these targets. So once again, the Passivhaus Standard is a great way to achieve net zero energy and then use that renewable energy to the best of its ability. So some of the benefits of passive houses are that they provide healthy indoor air quality and temperature. There's a lot of comfort and quiet because of the airtightness. So you don't hear that construction noise or your neighbors, or so you have that sense of privacy. There's a substantial reduction in energy use and operating cost. There's simple and durable systems for heating because you're reducing the size and complexity of those systems. And then finally, there's just peace of mind. You can have resilient buildings. So if you have things like power outages or whatnot, the inside temperature is going to be maintained through that period, of several days. So you don't have that same concern when you have those kind of emergencies. So once again, health and wellness and resilience and comfort are notable. The icing on the cake is the energy efficiency. So a lot of people come to Passivhaus for those comforts and health benefits, especially with COVID. We're looking at making sure we have good ventilation systems and healthy environments. And of course, there's the benefit of saving energy and saving money on energy bills. Passive houses are all over the world. There are tens of thousands in 42 countries. It's an international movement, but they also come in all shapes and sizes. Passive houses are just not residential. They can be single family houses, but there can be schools. They can be industrial and manufacturing facilities. There's office buildings like Charter Telecom and BC as an example that was recently certified. There's towers. So here's an example in Vienna. But there are also student residence towers in New York, modular staff housing and prefab construction, affordable housing in Ottawa, as well as in Philadelphia. So there's all kinds of different building types. There's even a hospital that's being constructed for research labs, brownstone retrofits, assisted livings, supermarkets, pools, fire halls. You get the idea that it spans a large range of projects. So the basic principles of a passive house, there's 5 of them. So we super insulate the envelope. We do airtight construction. There's thermal bridge-free design, and I'll explain that a little bit more. High quality windows with solar orientation. We really want to take advantage of the sun. And finally, ventilation systems with heat recovery. When we're exhausting that air, we want to capture the heat out of it. So when the fresh incoming air is coming in, we're preheating it with that outgoing air. So the passive house standard has some metrics, 15 kWh for space heating, 0.6 ACH at 50 for air tightness. There's a primary energy target. I'm not going to go deeply into that today, but we'll hit some of the points. The energy modeling software that's used is called the Passive House Planning Package. So you may hear that when you're working with an energy model or other design professional that's doing the model for the building. But once again, we're looking at low U values, below 0.15 in general. So you're generally at our R40. We want to reduce the heat loss in winter, reduce heat gain in summer, make sure we have a very comfortable interior surface temperatures. So basic principle, the more surface area there is, the more heat loss there is. So when we take a compact shape, there's less surface area to volume ratio. If we take a piece of that envelope and then remove it and move it to a different section, we're increasing the amount of wall area. And if we take it out of a chunk here, we're having even more wall area and more potential heat loss. So you can do these types of things, but then in general, you're probably going to have to increase efficiencies elsewhere. So this is not an optimal form. This can also be challenging as well. We want to keep the thermal envelope and the air barrier as simple as possible, and then You can still do decoration and ornamentation inside and outside of that thermal envelope, but we don't generally want to puncture it or create a lot of undulations in the envelope in general. So here's, current BC building codes, and here's kind of the targets that we would generally be trying to hit with Passivhaus: R40 for the walls, R60 for the ceiling, R30 for the floors. So there's kind of two different ways to add more insulation to the walls. You can either stuff it in the walls or wrap it around. And generally what would the common ways of doing this are a double stud wall or having exterior insulation strapped to the outside. So there's a lot of different ways we can do this. And my co-presenter will go into his projects in more detail. So interior insulating, thickening up that cavity with the double stud or having a deep stud cavity with a service cavity as well. That way we're not puncturing the air barrier, with wiring, plumbing, etc. The other way to do it is with Larson trusses for exterior insulation, or adding exterior insulation with cladding attachments. So please mute yourself. Thank you. And then so there's different ways we can do this. My co-presenter will go in more detail as well. We can do this in a prefab way for deep stud walls, and you can see the taping of that air barrier to make sure we have a nice airtight layer. And you can see how it goes on with cranes, and it can project can go up quite quickly this way. SIPs is another option. We see that happening in conjunction with insulated concrete forms as well for foundation walls, and but it can also be used for above grade. So the next principle, you have a nice you have a nice thick thermal thick thermal insulation, and so that's keeping you warm. You're wrapped in a nice jacket, so you're wrapping that building with a nice layer. Keep it warm, and then once again we want to make sure it's airtight, because if we have air going through that envelope, the insulation is not being effective. So we're reducing drafts, we're reducing the possibility of moisture buildup in the envelope by making sure the building's airtight as well. And we reduce heat loss in winter. We test this with a blower door test and general building envelope commissioning, and we find and repair leaks during the construction process. So the air barrier is quite important. It hits all of these different aspects of water, air, heat, vapor, management, sound, and fire. So we like to pay close attention to that, and it's recommended that in general there's a person that's responsible for that on site. It's also important to really look at where the critical barriers are and making sure that they're continuous. So while you may not be designing this where those are located, you're responsible for the construction. So we want to make sure that there's complete connections between the different layers and that everything is functioning adequately. So the next principle is thermal bridge-free design. And so what is a thermal bridge? And we'll go into that. But really, we're looking at how do we reduce heat loss through the different junctions of the building. And the junctions are where they're most vulnerable to moisture buildup. So we really want to pay attention to these. And I would say that the Passivhaus standard, the details and how things come together and are constructed are what set it apart from others. So what is a thermal bridge? Anywhere that there's an interruption in the insulating layers. It could be a change of thickness of the insulating layers, and there's also anywhere that there's jogs. So there's these geometric thermal bridges, and this occurs because of the way energy modeling is happening, and so exterior dimensions are always used. So there's overestimating and underestimating that occur. But generally you have to take into account these thermal bridges. We all know thermal bridges look like this, generally like the studs coming through insulation. So even though that wall is insulated, there's more heat coming through those studs than through that insulation. Here's an example of a building in Chicago called the Aqua Building. It has these nice balconies, but unfortunately it's sort of built like a radiator. So you have these concrete slabs that are unbroken, and in the end, you're leaking a lot of energy. So having thermal breaks is really important in the design. So here's an example of a foundation, also uninsulated and leaking energy. Door frames are also thermal bridges. So you can see the moisture buildup and the ice buildup here, and it's the mold, so we can have health and wellness issues if we aren't taking care of how we're installing the windows and making sure that they're properly installed within the insulation layer to get the best performance of the window, and also to not have these types of problems. So the world's most energy efficient buildings are also healthier, more comfortable, affordable, contribute to a sustainable future. So we do thermal bridge modeling to assess these junctions. I'm not going to go into detail. I just want you to be aware of it. And we're looking at all the different junctions in a building and how the corners come together, the windows fit in, etc. So even though it's nice to kind of gauge where the thermal envelope should go, the designer, and then also in constructions, you're paying special attention to these details. So the next principle is high performance glazing. We have triple pane glazing that's performing at less than 0.8, so it's like about an R7. So it's a quite well-performing windows that we want to use, and generally the windows can be the weak part in a building. So it's really important that we take time and not only pick good windows, but also install them well. If we orient them correctly and they're designed well, triple pane windows can actually be a positive instead of an energy loss. So it could be really helpful to that design, and it's the only part of a building that sort of can act like a battery and actually capture when we need it in the winter. So how do we get that kind of performance? Well, we have 3 layers of glass. We have insulating fills between those glass and different types of coatings. We have thermal spacers. So these spacers help reduce the conduction through the window, and then we have insulation within these cavities. And then there's also really nice airtight gaskets to help with making sure we're not getting leakage through the window. All of these different points help with the performance and also the comfort in general. We've all been near glass on a cold day and been uncomfortable because of the drafts created. With a passive house and these types of performance, a radiator right at the window edge, it frees up space so you can actually have livable space right next to a window. So this is just showing, for example, going from single glaze to double glaze, the reduction in heat loss. But once again, when we get to the triple glaze, if they're designed in place correctly within the building, it can be used to capture that heat when we need it. There are different U values for different parts of the window. The center of glass is generally less of a place where energy is actually lost in a triple pane window. It's actually the frame is the weak point, and then also how it's installed within the building itself. So if you look at these windows, if the center of glass is the same, you can see that the smaller window has a smaller U value for the window because it has more frame. So using less small windows and a few bigger windows will actually be better in the end. So the example on the left, there's lots more frame compared to the example. The having larger windows also provides challenges depending on how large you go. If there's quite large, you might need a crane, which has its own challenges, logistical challenges, and costs associated with it. Also, if you go too large, there'll be steel reinforcing in the windows, which also could degrade performance depending. So there's a balance and a sweet spot to find for your projects. Their windows are certified components, so you can go into the Passivhaus database and find certified Passivhaus windows, and it has all the information that's needed for the energy modeling. So that makes it a lot easier for the designers. Here's some example of Passivhaus certified windows from companies in Canada. The insulation, once again, it's recommended that it in the insulation layer. Otherwise, if you place that window outside of the insulation layer, you're actually degrading the performance. So you're spending a lot of money for a high performing window, and then you're cutting the actual performance of that window if it's not installed in an optimal way. So that's part of that detail aspect of Passivhaus that's important. So if you take care of the details, you have a lot of, if you take care of the details, generally the rest of the project will work out in performance. So the next part is mechanical ventilation. So once again, we want balanced mechanical ventilation and to be able to have a heat recovery. Nowadays, the heat recovery units are about 90% efficient. So they're really high performing. So we can have that continuous fresh air coming in, but not have the penalty for energy loss. It also comes really useful during things like forest fires, making sure you have clean air that's filtered, instead of having, your windows open at that time, you have to shut up the house, and having the heat recovery ventilator is useful for that, as well as for things like COVID, since there's no mixing of the air. There's a membrane in between that transfers that heat between the two streams of air. Finally, you just add a little bit of heat. So that can be done through an electric duct heater, but we're seeing more and more air source heat pump being used. So that's kind of the basics of the heating side, but strategies that need to be involved. You don't want to overheat the space, so making sure you have low internal gains as well as solar shades is important. There's a criteria that you can't overheat more than 10% of the year. 5% is the recommended value, and because we know how the sun, how the Earth is tilted, and the sun seems to move lower in the horizon, that we can take advantage of that and make sure our overhangs are designed correctly, and then we can use things like shading devices. External shading devices are being used more and more. So why certify? A Passivhaus is not the same thing as a Passivhaus-like or inspired building. having that quality assurance is really important. And the only way to know if you have a passive house is to go through the process, make sure the energy model's checked, to make sure that the construction is done well, etc. So there are different things that are certified. There are people that are certified for designers and consultants and tradespeople, and there's building certifiers who help check the work of the designers and tradespeople. There are components, so the different components like windows and ventilation systems, etc. And finally, buildings are certified. So there's the passive house building, the Enerfit and low energy building certifications. Enerfit is for renovations. There's criteria for these. These 5 different building standards. You can find it at the link below at passivhauscanada.com. And then these are updated regularly for clarifications and the like. If you're looking to hire a certifier, there's the North American Certifier Circle, which has a plethora of certifiers to choose from, and then also you can go on that same website that I gave you before to look for a certifier. Generally the info that you're providing is the working plans, a brief description of the assemblies and mechanical systems, the preliminary energy model if you have it, and then who's responsible for the energy model, and will be the link to the certifier, the schedule, and any known challenges that you might have. Generally, there's 4 stages to this, and of the certification process. There's the pre-submission, which is kind of a consulting phase during schematic design, and then the design stage review, which is important to make sure the building is that as designed will meet the standard. And then there's the construction stage where you as the builder will be working on the construction, and there'll be some testing involved during that time as well as at the end of the construction phase. Generally, people are submitting their projects for design stage review. That's the best practice. And then the final submission, there'll be the post-construction assessment. So Passive House is a team sport. It takes all of the different professions working together to make a passive house. All that information is in conjunction with a consultant or designer. Sometimes a member of the team that's an architect or engineer or builder could be the consultant or the designer as well. And so there's certifications for that. All that information then goes to a certifier who then reviews that information and will do the final sign-off. And there's all of these. Finally, the information is given to the Passive House Institute, where the information will be signed off and a certificate issued. And if you like, your building can also go into the database and be recognized internationally. So how do you get up to speed or become a certified professional? We offer courses. So there's of House Canada. There's the pathway for trades. So the next one for that is coming up in April, so you can look into that. There's also a pathway for design professionals where it has 3 courses bundled together. So please check those out as well. So once again, just going into the 4 stages in a little bit more detail, and then I know I'm running over time, so I'll be handing it off shortly. So pre-submission guidance is really important, just to make sure you are hedging all your bets, and that you're, especially if it's your first project, go to a certifier early, make sure you know what's involved in what you need to do. It'll save you a lot of trouble, time and money. Design stage review, making sure that the building is going to meet the standard before you start constructing. This is really helpful and important. Failure to submit a formal submission is the #1 reason projects don't certify. So this is the process. Generally, their submission, and then some feedback from the certifier, and that process happens cyclically until the issues are resolved and a design stage assurance letters is so then the construction happens. Generally there can be site visits and reports issued depending on the complexity of the project and the scale. It's really important to notify your consultant and your certifier if any change orders are happening. So changing out different components that may have a different performance level will definitely impact your ability to certify. And then finally, in post-construction, there's photographs and site visit reports, and then any remaining items. Here's just a checklist of different things that you should take into consideration, like airtightness testing, ventilation, occupancy training. So photographs, it's really important to have tape measures to show the amount of insulation. Representative samples of the different specs of the actual materials used is really important. So here's just examples of different details and how they were sealed via airtightness and then insulation. And then finally, airtightness testing is really important to hit the number 0.6, and there's a pressurization and depressurization test. And then you basically take the average of those two results to come up with whether you meet the standard. And then it's also important, I wouldn't leave this to the end of the project. You want to do it intermittently to see where you are while the air barrier is still accessible, so you can do any plugging of holes as you go. Ventilation commissioning is really important. We want to make sure we have balanced ventilation between the incoming and outgoing air, and we're making sure we have in the right points and the exhaust air at the right levels as well. And then finally, just declarations saying that the construction manager signs off saying that they've built the building as designed, and then list any deviations from that design. And then finally, there's an occupant education component. We make sure that the residents know how to operate the building and maintain it. So it can be a small little booklet that goes into the maintenance / mechanical room. Just giving acknowledgments to MISU, RDH, City of Vancouver for some of the slides. And here's the resource again for the criteria and building certification guideline. You can go to that link. Here's some additional resources. And finally, here's my contact information if you have questions.